Good morning, everyone. I believe that uh, any one of you can see my screen. So, in case you may post your questions here via chat box. Hello, guys. I am offering a free course including service discovery, microgateway, API gateway, cloud configuration, circuit breakers, tracing, monitoring, and testing. Specifically, I'm using Spring Boot 2.5, Spring Cloud Gateway, Spring Cloud Kubernetes, Spring Cloud configserver, Sleuth, OpenVein REST template, Mac APIs, micrometer, Spring Cloud security, and JWT. So actually, this is for free course, and then also if we talk about mastering microservices resilience with Spring Boot 2.5 and Spring Cloud Session 1, that means we're going to start with the basic, from the basic to master level that I'm going to share with you. So regarding aims and objectives, our target one is you need to understand first about microservices design patterns, and then you'll be able to migrate from monolith to microservices, and then also you can provide the immediate Mac APIs to the front end dev, and then also you can reuse the same design and the updated microservice template. And then for the target 5 is you're going to use the microservice gateway. You will understand the differences between API gateway, AWS, GCP, and Azure. You will understand that the differences between them. The next, then you'll be able to address the microservices challenges. A lot of people talk about the microservices. It's very difficult to develop. It's very difficult to handle when it comes to monitor hundreds of microservices running on the different nodes and cloud. So I hope that you'll be able to address that microservices challenges. Based on my experience, I was able to address that. So I'm going to give you some tips. The next is target 7. You'll be able to deliver the benefits of microservices container platform. So when you design the microservice, when you deploy and develop and deploy, you're going to need to deliver the benefits of microservice container platform. So there are specific the benefits that you need to know. Okay, and the last one is target 8. But you need to know how to develop the microservice. You need to know how to deploy the containerized microservices. So that is our objectives here for this course. What we will see today: deduction, about me, subscription, design patterns, dev setup, microservices dev, integration, deployment, and questions. So as you can see that we have another questions that you can post your questions in the chat box on YouTube. So the next slide. This is about me, so I'm going to introduce myself first. I am leading the technical strategy and vision to challenge business and technical constraints to achieve a solid design. I specialize in designing and building API management, containerization, microservices, E2E data encryptions, hybrid cloud infra setup, multi-cloud application development, DevSecOps, and big data solutions, plus migrating legacy services and APIs into the microservice containing platform, and you will realize the benefit of high scalability, high availability, self-healing, and strong security. I have 16 years of working experience in full stack development and architecture, including web service, APIs, micro front end, digital signatures, JWT, and web development with different businesses such as banking, financial, fintech, and telco, plus integrating the payment gateway or intelligence using iPay 88, InstaPay, PCHC, PayPal, Mingaling, BPI, BankNet, Visa, and MasterCard. I have 7 years working experience in designing and developing microservices and API management, plus 7 years of working experience managing and provisioning the public cloud computing with on-prem automated infrastructure, VM or cloud migrations, and containerized microservices architecture in an organization, especially as cloud technologies such as AWS, GCP, Azure, IBM Architect, Red Hat. So and then I have accomplished 27 plus cloud certifications. Specifically, I have 6 Red Hat certified. I have 4 AWS Proof certified. I have 5 GCP certified. I have 10 Azure certified, 1 Cloud Foundry certified, and 2 Kubernetes certified. If you have any questions about my course, you can reach out to me via email jesseryj@outlook.com, and then also you can reach me through Twitter or Facebook. So, okay, again, I'm going to share about the Microservices Bootcamp registration. For those of you who haven't yet registered with Microservices Bootcamp registration, I cannot provide you the source code. So I cannot share the source code from the GitHub. But it's okay that you're going to join on this YouTube channel and you can watch this video. That is fine for me. So I'm going to share the source code for those who already registered with Microservices Bootcamp registration, because I'm going to invite you to join and sign with GitHub. Okay, what I offer here, once once I shared the same source code template to you guys, do not reclaim or resell the same source code template, because this the template is open to everyone, and then you can also use the same source code template to develop for your project, and then also you can start selling your project to different the clients. So the first is initial is free. I'm going to provide the template, Spring Boot Cloud template, Spring Cloud template, distributing tracing, and but there's no warranty if you encounter some issues, but it's guarantee there's no issues with the template. So with the initial template, you you're going to need to finish the remaining session until you be able to get the complete the source code. Okay, for the next one, the complete, if you don't want to wait to finish the remaining session, you can get the complete the source code, the complete source code, and then also you'll be able to get the access from private GitHub contributor rule, and then I will provide the template maintenance update. For example, our Spring Boot is version is 2.5.2. If we wanted to update the latest version for the framework within 1 year warranty, I'm going to update. And then so also there's no issue with the vulnerabilities. Then I'm going to provide also the manual guide. As long as you are subscribed member. Actually guys, this is optional. I don't think it is required for you to choose the complete if you don't want to wait for the remaining sessions. So for those who are interested to get the electronic the certificate, you may pay 100 pesos plus initial the template. Okay, so I can issue the electronic the certificate if you complete it, if you already completed the session 1 and the session 2. Okay, for the next session 2, we will be talking about messaging, and then also cloud scream. Okay, in case if you don't in case in case you don't want in case you don't finish the remaining session, I cannot issue the e-certificate, so I will return the money to you because I'm using my complete name. I'm the one your I will be the one your coach to train the course for you. So my name is really exposed, so the company expecting you that you be able to familiar with the microservices development, and then also you be able to address the challenges. In case you don't finish the session 1 and session 2, I cannot issue the electronic certificate. Okay, I'm going to return the money to you. So if you have more questions, then you can post your comments. So if you don't want to pay for the complete the source code e-certificate, that's fine. That is optional, but I'm going to provide the source code, the initial template. So, so regarding the source code template, what I have the special offer is to provide you the template maintenance. So what I do here is to update the latest Spring Boot version and the Spring Cloud version until 1 year warranty. Unlimited download. Of course, you're going to download the source code complete from private GitHub repository. The third one is manual guide sharing. I'm going to to send you an email. Of course, you'll be able to get access from the GitHub repository, and including the manual guide sharing, technical development. Also, you'll be the one to modify with the template as a contributor freely. So then, if you have more questions about the template, I'm going to coach you on a Facebook group, and you should join the Cloud Microservice Certified Professional so that everyone can read our posts, risks and solutions and issues. So the key to features for the Spring Boot and Spring Cloud template, I'm going to provide the JWT authorization and authentication, multi-layer Docker image, microgateway, open API spec swaggers, Mac server swagger UI. When you say Mac server swagger UI, you'll be able to see the swagger UI, and then you'll be to create the constant API Mac. You don't need to create the database, guys. So it will also automatically generate the service URL endpoint. Then you can start the development. Once you started the API development, you can share it to your front end team so that you'll be able to start the design the front end without affecting their timeline. So again, you'll be able to access the source code from the private GitHub repository. Okay, your question is your question from Ryan. Will the GWT section be covered for the stateless across different services regardless of the language used? Yes. So we have a different languages here, like Java, Kotlin, and Groovy. If you are familiar with these three languages, yes, that is fine that you'll be able to use the JWT regardless the programming language they develop for the microservice. For example, if you have the PHP, if you have no Node.js, they will be able to access the JWT header so that you'll be able to execute the API from microservice. Okay, and then Kubernetes application development. I'm going to provide the deployment, a YAML file, and service, how we expose the service outside the network on the Kubernetes. Okay, so from there we have deployment YAML file, and then service YAML file, secret, and the config map. So everything is there needed for the production. So when you get the source code template, it is ready for the production that you're going to deploy. Okay, guys. So then you will experience rolling update and no downtime. Meaning to say, you'll be able to update the microservice without needed to shut down the entire applications. For example, the first one microservice is currently deployed, and the version 2 you're going to replace the one with the version 2. so without experiencing downtime, something like that. And then also microservices monitoring dashboard, especially guys, you're trying to purchase the monitoring from different vendors because they have already complete the integration and monitoring, but you will charge more. Unlike here, microservice monitoring dashboard, actually that is a microservice. When you create a dashboard using Spring Boot admin, that there is no charge. Actually, they're the same. When you deploy the monitoring like Yaker, tracing, something like that, microservice monitoring, GBM, so you don't have to install that. So we have a microservice monitoring dashboard. So good questions. Thanks for the questions. I'm going to talk about migrating from monolith to microservices. You need to be aware of which of these microservices design patterns you're going to use for your migration. Before your migration, you need to design first. You need to understand first about the business requirements before moving to microservices. So microservices is the new normal. It is a modern approach to application whereby application code is developed in small, manageable pieces and independent services. The second one I'm going to discuss, monolith to microservices, it shows how we decompose from a single unified unit to a separate services. The third one is microservice design patterns. You'll be able to understand that design patterns when you develop the microservice. Now I'm going to discuss about banking system. So actually the monolith design is not outdated and it still works in some cases. Monolith application, every small update requires a full redeployment. Thus, all developers have to wait until it's done. When several teams are working on the same project, agility can be reduced greatly. If there's a need to add some new technology to your applications, developers may face the barriers to adoptions. Adding new technology means rewriting the whole application, which is costly and time consuming. For example, we have the banking system here. We have one application containing deposit, withdrawal, payment, fund transfer. Here, we have one application deploying and running in a single environment. We have the single applications containing different backend business logic such as deposit, withdrawal, payment, and fund transfer. So for me, it's difficult to adopt new technologies here. Most products develop and increase in scope and their structure becomes blur. It becomes difficult to understand and modify, especially for new developers. It also gets harder to find side effects and deficiencies. With a growing code base, the quality declines and the integrated development environment IDE gets overloaded. That's the problem that we're going to address. So moving to microservices design, we're going to split a monolith design into smaller microservices. So microservice is a type of service-oriented software architecture that focus on the building series of autonomous components that make application. Unlike monolithic application built as a single invisible unit, so microservices consist of multiple independent services that are containing the APIs. So we have the different external applications here, such as mobile, web UI, desktop, third-party applications. So any application can access the microgateway. So the microgateway, it's one of the gateway that we're going to use for accessing the internal containerized microservice. So I'm going to discuss later about the microgateway pattern. So for example, we have different database here, such as user financial audit transactions. Okay, so we're going to also split into a smaller database instead of creating a single database containing multiple functions. But the problem is it is harder for us to scale the database, the number of database from 1 to 2 or to 3. So that's the problem about that database. It's hard to maintain. It's hard to increase the number of instances. So we're going to split the database here into smaller database. So as you notice here, we have the different instances of deposit of microservices. So from 1 to 2, from 1 to 2, from 1 to 2 here. So it can be scalable from 1 to 2 or 2 to 5. It's up to you. So it's easy for us to develop microservices when you get started, especially for the new developers. So you can choose any programming language for you to use that. So with microservices, we have the several teams can work on their services independently and quickly. Each individual part of application can be built independently due to the decoupling of microservices component. For example, you may have a team of 100 people working on the whole application like in the monolith approach, or you can have 10 teams of 10 people developing different services for that application. So let's imagine that visually. Okay, so you're not going to work on the single application just like a monolithic approach. When you're talking about a microservice design, then you can switch to different microservices that you can work on. So you can have 10 teams of 10 people developing different services for the application. Okay, so this is how we migrate from monolith to microservices. Once you have the single and unified unit containing different business, then you can migrate to microservice. For now, it's easy for you to migrate the microservices, especially because, as you already saw this my example. For the next slide, maybe we have a little discussion, yeah, regarding that. And then also I'm going to discuss the differences between vertical scaling and horizontal scaling. With microservices, vertical scaling running in the same software but on bigger machines can be limited by the capacity of each service. But horizontal scaling, when you're creating more services in the same pool, is not limited and can run dynamically with microservices. Furthermore, horizontal scaling can be completely automated. Okay? Unlike a monolith design, you're not going to use the horizontal scaling because it's impossible for you to scale up the monolith application because it's too huge the size. So what you can do is to scale the monolith application. Maybe you can use the vertical scaling, but on bigger machines can be limited by the capacity of each application. So regarding the security concerns about the microservice design, each functionality that communicates externally via an API increases the chances of attacks. So these attacks can happen only if proper security measures are not implemented with the building app application. For example, you're not going to use the JWT as long as that you're going to deliver microservice and deploy them to the container. So it's I'm worrying about that, the security concerns. So when you design a microservice, so security always comes first. Okay? So splitting an application into independent microservices entails more artifact to manage. This type of architecture requires careful planning, enormous effort, team resources, and skills. The reason for high complexity are the following: increased demand for automation, as every service should be tested and monitored. Available tools don't work with services dependencies, and data consistency and transaction management becomes harder, and each service as a database. So what I'm saying here are the challenges. I already addressed with that challenges. So these challenges that was before I encounter today, and I was able to address with the challenges. So I'm going to share to you. Once we have the template can be reused for every development. Do not rework or work on the microservice development from scratch. So it's hard for you to design without defining the security without defining the template first, and then without defining the exact the service dependencies. So every microservices uh, as included, tested, and monitor applications. That's good questions for Herald. What's the true value of microservice? Yes. Uh, so I believe some people complain about microservices. It requires a lot of effort to work on the service dependencies for each microservice. That was before. That was before actually. Then with the current company, I was able to address the challenges. So once we have the template in the GitHub the repository, every microservice needs to be replaced with the new template or the current template. And then also the service, the template is containing the standard Spring Boot framework version, Spring Cloud version, and then also dependencies. So you don't have to change that anything with the template because it will affect with your team that they are not familiar with the template. The first to discuss with your team about the template, they need to get the familiarized with that before starting the development. Okay, guys. And then also, of course, from when you start the development, I don't think it is hard for you to update the latest the framework. When the client decides now to get the latest the framework because of vulnerabilities, guys. Unlike the monolithic application, you have to rework on that single application because there's some codes are not compatible with the latest version. That is the monolithic approach. So what are you going to do? You're going to create from new, or you're going to migrate to the whole applications, the new version, then you're going to rework on the existing code. Unlike the microservice, if for example you have the Spring Boot 2.3, right, and running on the container, so I'm going to create another new microservice with the latest framework. Then once I deploy it, the old microservice will automatically be replaced with the new one. So I don't think it is hard for that once you understand the design patterns and architecture patterns. If you are already familiar with the containerization approach, actually it will address all the challenges regarding the microservice. Unlike the monolithic design, it's not applicable for containerization approach because in my current project, I have a team. We have a different teams there, but we have also different architect. One of the teams there are deployed the monolithic application to the container, and they will experience the performance issues, and then also they will experience the startup. Okay, thanks for the question, Harold. So when you start the small development, I would suggest you to start the microservice because in the future application, then you're going to expand on your business by adding another microservices. With different microservices, everything in the outside the network, like external application, they will be able to execute your microservice, to use your microservice to produce the exact business. When application is large and needs to be flexible and scalable, this is it. The microservices are beneficial. So, okay, at least we can compare the two software architectures to define the differences between monolith design and microservice design visually. Okay, so once you have a monolith design application, guys, like the banking system, you have a different business logic here, then you can easily split into microservice. So I'm going to teach you about design pattern, what we're going to use that. Okay, that's it. Let's start with a microservices design patterns. So we have, I guess we have a different microservice design patterns here. The first one is decomposition patterns. There are two decomposition patterns. The first one is decomposed by business capability, and the second one is decomposed by subdomain. So I'm going to refer you. And the first one is breaking down the monolithic application services into smaller services that are labeled as deposit, withdrawal, payment, and fund transfer. So as a result, it becomes more scalable and predictable. So this is what I give the previous example in the previous slide, right guys, about the banking system. So now if you want to use the second one, which is breaking down the services domain model into separate subdomains that are labeled as cash deposit, check deposit, cash withdrawal, and check withdrawal. So it can create too many microservices, which makes service discovery and integration too difficult. It's much more complicated when you use the correct incorrect design pattern. So this is what I'm talking about earlier, when you ask me the challenges regarding the microservices, because you choose the wrong pattern when you decompose the business requirements. So I would rather choose the decompose by business capability, and based on the business requirement, are splitting into smaller services like deposit, withdrawal, payment. Within deposit microservice is that contains two deposits, such as cash deposit, check deposit. So what we are calling them, that's a cash deposit API. The check deposit are included in the deposit microservice. So that's it. So I rather choose the first one than the second one, so that it will not create two microservices. When you have the deposit microservices, all service and function should be implemented in the deposit microservice. For example, we have deposit microservice. We have different bankings there. Bank BPI deposit, RCPC deposit, and what else? GCash deposit. You're going to use the GCash deposit. In terms of deposit functionality, do not include another functionality which is not related to the deposit, guys. So it's more on only the deposit microservice, guys. When when you develop. Okay, when you design, when you talk to your business analysis, you have to explain it why we should not include the other business in the deposit microservice. Okay, so of course it can be more complex and complicated when you design that. Okay guys, another pattern I'm going to talk about service discovery pattern. With service discovery, your microservice will automatically be subscribed or registered without even knowing their IP address. They will be able to communicate with each other through service discovery as a ticket way to get a successful response from other microservices. In the same way, guys, when you purchase the ticket from the cinema, of course, you are going to present your ticket to guard, or you're going to scan your ticket in the machine, and then you'll be able to get entering without knowing your name, as long as you have ticket. So this is what I am talking about, service discovery pattern. So with the microservice, they don't need to know about your port and IP address. As long as you have the service discovery within different nodes, different containers, as long as they are the same network, they will be able to communicate with each other through service discovery. So they are the popular service registry or discovery, the plugins we may choose. The 5 years ago, I was able to implement microservice using Netflix Eureka. That was before. As of now, Netflix Eureka, it's not outdated. It's not updated version. The version is still the same, so it doesn't change anything. You're going to use Eureka, but the problem is there are some issues regarding the vulnerability, the security. That's the problem right now. So I don't use the Netflix Eureka anymore, even though it has maintained by the Spring team. So I rather choose the new design and the plugin called Spring Cloud. The Spring Cloud, we have a lot of different plugins, guys, there for the Spring Cloud. For example, Spring Cloud Kubernetes. When you have the Kubernetes, OpenShift, container, or any container platform, you can use the Spring Cloud. Okay, so when you use the Netflix Eureka, guys, it doesn't need for the containerization approach because we have the service discovery application in the Kubernetes and OpenShift. Okay, so if we wanted to use the Eureka, that is fine for the practice, for the small project. If you don't want to use the container, so it still works. If you wanted to deploy the Eureka with the container platform like OpenShift and Kubernetes, it is still work. It is still working, but you have two services discovery. So I don't think there's another to conflict with the service discovery, but the container itself is confusing with your microservices. Uh, let's say you have another service discovery in Kubernetes that is already registered with your microservices, and then Eureka is also registering another microservices for that service discovery. So with the container itself is confusing. So you have two running applications inside the container. Okay. The third one's console that is developed by Azure Corp, but you still need the platform to be installed inside the container of virtual machines. So console, we have another the plugin, then we can use in that the service discovery. But for me, I don't need that because, for example, I'm going to use the Kubernetes and OpenShift the platform. I don't need console. Then I'm going to use the Spring Cloud the plugin to be integrated with the microservices. It is still working, so I don't need to work on extra platform like console. And the last one, Zookeeper, that is developed by Apache. So actually they're all the same, but the different features. If you mix anything with the Eureka and Spring Cloud together to be integrated with the microservices, so it's possible it can be more complicated. So someday you will experience the performance why running slow. It will be overwhelmed by sudden increase in requests because you have two services discovery running inside the container of virtual machines. So thanks for the question, Herald. So I think I already answered that question. Herald asked me what are the strengths of each service discovery. Okay, Netflix Eureka, that is good for virtual machines. That is not good for Kubernetes and OpenShift because you have already service discovery inside the Kubernetes and OpenShift platform. So the question why we need that Netflix Eureka, the plugin for that microservice, I don't think it is needed. So okay, the problem is you're going to create another instances for the Eureka. You're going to create a Eureka for instances to manage the load. When you deploy it inside the container, the time will come, then you will experience the load because of different users' requests. You're going to add another memory for the Eureka. With the Spring Cloud, that is not platform. So we have the plugin that is supported with the current OpenShift and Kubernetes. So Spring Cloud service discovery, that is good for the containers and virtual machines. For example, when you deploy the Spring Cloud service discovery with in the virtual machines, there's no service discovery platform. I guess the Spring Cloud, there's no platform to work on that Spring Cloud. It doesn't connect with the microservices. Okay. Okay, Vincent, thanks for the questions. Another question is Kubernetes an alternative to Eureka since it's already outdated? It's optional. It's up to you that if you wanted to use the Eureka the plugin, but when you use the Kubernetes, you have already their service discovery platform. That service discovery platform is not automatically connected with your Eureka plugin. So meaning when you launch the Eureka plugin inside the Kubernetes, you have extra service discovery. So that is not connected to Kubernetes. So Spring Cloud Kubernetes, that's the plugin. It will automatically connect with the Kubernetes service discovery and OpenShift service discovery. Okay, thanks for the questions. The last third one, console herald. The strength is, if you don't want to use the Kubernetes and OpenShift, then you can use it for virtual machine. Then you need to install the console platform. Platform itself should be installed in the virtual machines. Once it's running, your microservice for service discovery plugin will work. Okay, so it is still working, but without the console the platform running inside the virtual machine, your microservices are useless. Okay guys, useless. Unlike Kubernetes or OpenShift, you have already service discovery. You don't need to install anything in relation to the service discovery. Okay, and aboard the Zookeeper, that is fine. You can even deploy the Zookeeper with the OpenShift or Kubernetes, but the Kubernetes doesn't know what kind of service discovery platform that you're using, so it's not automatically connected. Same issues. So I rather choose the Spring Cloud for OpenShift and Kubernetes. Other than, then you can use the console, Zookeeper or Eureka. For the Eureka, I guess we have some security concerns for that, even though it has maintained updated by the Spring Cloud team. When you look at the source code, when you scan that Eureka plugin using Maven dependency check, so there are some vulnerability issues, guys. It's possible for you to experience that security error. It's possible to access your code. Okay, thanks for the questions. So do you have any questions for this one? I hope it helps. Okay, this one, guys. The third one is microgateway and API gateway pattern. So when you deploy the microservices running inside the container, then most likely people are trying to access directly to the internal microservices containing different APIs. So it is not recommended for that, because internal microservices can be exposed outside the network. So when you have a SQL inside the microservice, meaning it's possible to inject the SQL even though you have the database security servers, private network. Is it possible for injecting that SQL inside your database or microservice? So instead of direct access to the internal microservices containing different APIs, we're going to use the microgateway which is the breach that makes internal microservices invisible to the internet and protects access to your internal microservices on the private network. All the private is routed through the microgateway. So where in we don't have SQL statements and database in the microgateway. So there are many security features of the microgateway such as SQL injection defense, cross-origin resource sharing, certificate management, and security logging. So you will notice that there are no sensitive data inside the microgateway logging. Every time the user trying to access the microgateway and they are submitting the request to the microgateway, and you will not be able to see inside the logs microgateway the sensitive data. You cannot find it anywhere. When the certificate management, it's instead of doing the certificate for each microservice that you're going to expose, so it is hard for us to renew the certificate in each microservice, which is not recommended. So you have to use that API gateway or microgateway to manage the certificate. It's just one for gateway, then you can easily renew the certificate. Okay, so for the cross-origin resource sharing, there is a mechanism that enable us to access the certain server and resource. For example, your front-end application is deployed in another different server and trying to access direct microservice which is not belong to the server, so it's not possible for you to access. It is not working. So you get the course issue. You will experience the course issue. So that's what we're going to do about design pattern in terms of security concerns. When you have the micro gateway, you don't need to worry about the internal microservice to handle the security such as the SQL injection, cross-origin sharing, certificate management, and security logging. So there are different API gateway platforms of plugins we may choose. For example, AWS, Azure, GCP API gateway platform. If you have a lot of money, of course, guys, you're going to invest that with a lot of money for AWS API gateway. So you don't want to worry about that, the security concerns. That's okay, no problem. But if you have a small company and they're not willing to invest that with the Azure API gateway platform, what is the other way? Can we have that? Of course, we're going to use Spring Cloud Gateway plugin. So that's another microservice gateway going to implement instead of using the third-party platforms like WSO2, Nix Plus. Actually, guys, it's also free Nix, but that's not the plugin. That's a platform. Nix API router platform. That's number 5. That is free, but when you design the advanced the API routing configurations, you're going to upgrade another subscription for Nix Plus. You're going to upgrade that because you're going to use advanced configuration for like API. For example, API rate limiting policy. How can we do that? So the first thing is API rate limiting policy, meaning you're going to limit the number API requests from users. So they cannot execute the multiple APIs at the same time. They cannot do that. So that's what we going to use, the API request rate limiting policy. We're going to limit the number of requests so that you will not experience load because they are unnecessary requests. Okay, guys. So if you wanted to change the API request rate limiting policy, then we can choose AWS, Azure, GCP, WSO2, and then also number 5, but you're going to need to upgrade the next version, Next Plus. You're going to pay that. But for me, I don't need that because with the Spring Cloud Gateway plugin, I can also use the API rate limiting policy. There is a configuration. So why should I choose AWS over the Spring Cloud? Guys, I did not discourage you to stop the using that. So in terms of costing for the small companies, but you have big companies, of course they're willing to invest with that AWS, Azure, GCP, API Gateway Platform, or WSO2. In WSO2, meaning that is API management, including different web services, APIs, and also microservices. You're going to manage that, then you can publish your APIs to the public. Okay, so if you ask me is it possible for me to use both Spring Cloud Gateway plugin as well as AWS or WSO2? Yes, it's possible. That's okay. So the first thing, because AWS, Azure, GCP, API Gateway Platform will be able to access the Spring Cloud Gateway. So the Spring Cloud Gateway, which is containing the different microservices, then which is containing the different APIs. So you don't have questions? So there are chances some I encounter before some developers and that saying that we don't need to use the micro gateway API gateway. So there are chances trying to direct access to the internal microservices, which is not highly recommended for that in terms of security concerns. So once you understand this, so meaning you are the practitioner, you understand the keys and issues. Okay. So there's a difference between platform and plugin. When you say platform, that is a software already developed, then we can install it. When you say the plugin, you're going to use the plugin in your framework to be used that. Then you can develop, you can create the source code to protect the APIs. That's a plugin. So you don't have to install anything. So with the Spring Cloud Gateway or Netflix API, so you can use that. The difference between two, Netflix API cannot handle the multiple non-plugin APIs access. Meaning, once you deploy the API into the container and then you have another microservices deployed into the container, but the Netflix API cannot load all microservices at the same time. it will take some time to load that individually. Unlike the Spring Cloud Gateway, so it will load all the microservices. It can manage concurring, and then non-blocking APIs. Again, we don't have the SQL statement and database inside a microgateway or API gateway pattern. So, what's the difference between two API gateway and a microservice gateway? Okay, when you use the API gateway pattern, it is not focusing on the microservice approach. So meaning to say that you are targeting the API. You are targeting the API to able to load on the API gateway. For example, we have the services, so of course we can call that API. I don't think that the API is for. I don't think APIs is the same with microservices. No, so APIs is the single function as an application, while microservice there is a business capability. When you have a microservice, meaning you are developing API in relation to the exact business. For example, deposit microservice, all APIs related to deposit should be implemented in the deposit microservice. That is what we call here microservice gateway. We're going to use that. So we should not confuse with a microgateway as well as API gateway pattern. But that's okay, you can use the API gateway. It doesn't matter because it's only for you to understand, because it is not for the client trying to understand that, because they're not technical. When you present it to the client, usually you discuss about microservice and sorry, I have another question. I'm confused. I searched for Spring Cloud Discovery on the web, but it leads to Netflix EDS, which you mentioned is not updated. Yes. When you try to download the Maven directly, when you try to download Netflix Eureka from Maven, Netflix Eureka means which is not maintained by the Spring Cloud. When you get the Spring Cloud Service Discovery, including the Eureka approach, and they have added another approach to maintain. For example, as I mentioned earlier, Netflix tool, and then also Spring Cloud Gateway. The Spring Cloud Gateway can handle non-blocking APIs, while Netflix tool cannot handle the non-blocking APIs. So that's different one. So when you download the Spring Cloud Service Discovery, that means it is updated, is maintained by the Spring Cloud community, Spring community. And then also, for the Netflix tool, Eureka Netflix for the service discovery, when you try to download directly from Maven and then try to install the plugins name Maven dependency check. So when you run the Maven dependency check, you will encounter that the plugins some issues in terms of security concerns, but the code's still the same. So, alright. So, yes, that's true. The Spring Cloud Service Discovery into it, but it leads to Netflix. That's correct, because they're the ones who maintain the Netflix for the service discovery to for the requirements of non-blocking APIs. Unlike the Netflix, you still need to work on that For example, when you deploy Netflix Eureka on the container, so the Kubernetes is confusing with your microservice that you have the Netflix Eureka service discovery, because you have already service discovery. Why can we connect with the Kubernetes discovery and Netflix Eureka? That's a question. Why cannot? Unlike the Spring Cloud Service Discovery, when you deploy that specifically Kubernetes plugin, it will be able to connect with your microservices through Service Discovery platform. Okay? So do not confuse with that. So when you say Eureka Netflix, so meaning the Netflix is the one who maintained the Eureka server, Eureka plugins in the main, but it's still the same. The source code is still the same. When you try to use the Spring Cloud Netflix, there are two types, guys: Spring Cloud Service Discovery, and there's another Spring Cloud Netflix Eureka. There are two types. So when you have assisting the design service discovery for the Netflix Eureka, you can use Spring Cloud Netflix Eureka, which is maintained by the Spring team, which means that the same source code, the same integrated with the Spring Cloud, it's still compatible. That is for legacy application. Okay, Spring Cloud Netflix Eureka. I used that before with my previous client last 2 years. So Spring Cloud Netflix Eureka. So before coming to the Spring Cloud Service Discovery, when you use the Spring Cloud Service Discovery, it doesn't connect with the Netflix. There are two types. You will notice that there are two plugins: Spring Cloud Service Discovery, and then also we have another Spring Cloud Netflix. Actually, they're not the same. The Spring Cloud Netflix, that is for legacy application. When you have that existing, it cannot be modified. You don't want to create from the scratch, something like that. But the source code, the same approach. When you try to scan the plugin using Maven dependency check, and then you will encounter some security concerns and about vulnerability. So thanks Ryan for the question, raising up the exact question, so the people will be able to understand that the differences between two. Actually, they're not the same. So even though in saying that Spring Cloud Netflix and another one, Spring Cloud Service Discovery, they're not the same features, because Spring Cloud Service Discovery, it's when you deploy that with the config shape, it's still working. So Kubernetes or OpenShift is not confusing with that. So any more questions about this before moving to another next slide? Okay, guys, externalized configuration pattern. Externalized configurations, the centralized configuration management that shouldn't be embedded inside the application in the cloud. It should easily be modified without needing to redeploy or restart the microservice. Okay, there are different externalized configuration platforms or plugins. Okay, guys, if you want to use the plugin like the Spring Boot, Spring Cloud Config Server, yes, you can use that. You can deploy the microservice to the container without using platform. With the config server, if you have added another Spring Cloud Kubernetes config client that is connected to the Kubernetes config mod, meaning when you have the application property inside the application that is connected to Kubernetes config map. Whenever you have the changes, the Kubernetes in the Kubernetes config map or OpenShift, so your application properties inside the application will not be in use. Okay. For example, OpenShift Kubernetes config map, yes, that is a platform integrated with Kubernetes. And Spring Cloud config server, that is a plugin. And then another one, Spring Cloud Kubernetes config for OpenShift and Kubernetes. So when you update the changes inside the configurations, externally configuration, you don't have to restart. So the only way you can change is to use the config map. Okay. For example, if you don't want to use, guys, the Kubernetes config map OpenShift, you are focusing on the PM approach, then you can apply the Spring Cloud config server. So Spring Cloud config server instead of updating the configuration individually per microservice, actually you can update the Spring Cloud config server inside the virtual machine. Okay, guys, so the problem is you're going to restart that. So without containerization approach, guys, your microservice always restarted. But not all microservice, only the config server will be restarted once you have made the changes. That's the kind of VM approach. Unlike the containerization approach, you don't need to restart. So just a microservice will be able to get the latest microservice. So we have another session for the next week. If you feel tired today, actually, so I'm going to finish this slide, and also I'm going to finish the dev setup. That's very important for the basic for you to. That's very important for you to understand the basic design patterns, and then also dev setup. Especially when you have new requirements, especially you have migrating from the existing project to microservice. That's a very challenging for you to understand the existing business requirements and business application, because there is not new one. You're trying to understand what is inside the application. Unlike the new requirements, unlike the new project, it's easy for us to get started immediately with the microservice development. Okay, guys. So externalist configuration, since you are familiar with the application properties, we have different kind of properties. For example, we have dev environment, and then we have prod, we have seat, we have UAT. So instance application that properties, that's the current configuration we are using for the Spring Boot microservice. And then you have another application which is used for development environment. So for that development environment, that will override the current application that you are using for the Spring Boot microservice. Okay, for example, application dash diff.properties, application dash seat.properties, application dash prod.properties. So when you choose the Spring profile or different environment, when you set to dev, so the application dev will be loaded, will be read. If ever you have the externalized configuration map, integrated with OpenShift and Kubernetes. So your application dev, it's still loaded, but it will be overridden by the externalized configuration integrated with OpenShift and Kubernetes. Okay. Okay. Sometimes you're confusing with APIs, you're confusing with microservices. People talk about they are the same. Actually, it's not true. So, microservices, that is a business capability when you design the requirements, and then also it offers a way to build web-scale applications by breaking a large application down into small and independent services, while the API is the function as a single application. For example, you have the deposit microservice. Now I'm going to ask you what kind of function that you're going to use for deposit microservice. Tell me. Cash cash deposit and check deposit. So there are two. So meaning you have two APIs inside the deposit microservice. It's very simple, guys. Oh, so deposit microservices is containing two different API functions such as cash deposit and check deposit. Okay. Now, the question, how does your business user communicate with you in terms of business functional requirements? Are you going to discuss about technical APIs or business APIs? So, most business user don't familiar with the technical APIs. When you talk about technical API, you're providing the detailed technical database, technical SQL queries, technical something like that. They want to know about that. When you present it to your client or business user, you can present the microservice requirement or business APIs. Okay. So as you can see, some people misinterpreted the API. So we have different kinds of API, guys. For example, web service. Is that a web service that, or is that a microservice? I'm confusing with the API. What kind of API that you are going to develop? Microservice or web service or monolith service, something like that. Of course, we're using microservice for the APIs, for the business APIs, something like that. When you're gathering the requirements, when you're splitting the requirements into small services or microservices, so the business user will be able to understand that. So they will ask you some question, why do you split into small services? Oh, you can explain provide the advantages in terms of high availability, high scalability, and then strong security. If you have, you don't have any more questions, guys, I understand you will get bored for the first time of discussion. I understand a little bit because it's very important for us to design microservices to avoid drawback of microservices and challenges. So then, what's I'm going to discuss about the benefits of microservices container platform. So what do you mean microservices container platform, guys? Is that the virtual machine approach? Can you tell me what kind of software for that a microservice container platform? So our software we are using are Kubernetes and OpenShift. That is a microservices container platform. Okay, so if you remove that the container platform, if you're saying microservice, you are focusing microservice, right? You're focusing microservices not in line with container, meaning you are in line with PM approach, or you're saying that you are in line with that microservice only. So the business user or technical user, you are confusing with the terminology in terms of microservices architecture patterns. For example, microservice container platform, our benefits are high availability, high scalability, self-healing, and strong security or resiliency. So there are 5 the benefits we're going to present. Yeah, okay. Good question, Vincent, regarding the Docker. Of course, we are using the Docker container. The rule of Docker is to build image locally in our machine. Okay? So once you deploy the microservice into the Docker containers, meaning we don't have a service discovery, we don't have horizontal scaling. You're setting the number of instances we have deployed inside the Docker containers. If you're going to add Docker Swarm, which is similar to Kubernetes and OpenShift, there's no problem with that. So I'm saying that we're going to use Docker for building the microservices and converting the microservices to image using the Docker. And then from the image, from the Docker image, you're going to deploy the Docker image into OpenShift and Kubernetes. So actually, guys, OpenShift and Kubernetes, they're not using the source code to launch inside the container. They're using either Docker image or Batman image. So when you deploy the Docker image inside the container, then Kubernetes will be able to schedule your Docker image and deploy. Okay? So if you want to test the microservice running locally in the Docker via Docker, sorry guys, I'm going to repeat. So you can even install the Docker in your local laptop or local machine. So the rule of Docker is to build Docker image from your microservices. The next step is when you launch the Eclipse, when you launch the microservice running locally and in line with the Docker and connected with the Docker, then you will be able to access the OpenShift and or Kubernetes in the cloud via Docker. You don't have to connect to the remote desktop. You don't have to connect to SSH. Actually, you don't have to do that, guys. So you'll be able to access the database from the Kubernetes and OpenShift via Docker. When you have a local Docker in your laptop, you will be able to access in the cloud. Guys, actually, you can run it locally. You can debug the source code using the Eclipse or Spring Tool suite and running in locally via Docker. Then you'll be able to access config map. You'll be able to access service discovery. What are the services the running available inside the OpenShift and Kubernetes? Our Docker is the bridge so that you'll be able to access to different containers in the cloud. You don't have to connect to SSH and remote desktop. That's what I miss. Okay. Thank you for the questions, Benson. So I'm going to discuss about high availability, guys. Oh, right. When you present it to the client, you can say the microservices can be replicated across the multiple regions, meaning you have deployed different containers to different regions, which is the nearest place to your current region. That is a high availability. You will not experience downtime, something like that. For example, if you are here in the Philippines, so your microservices is gonna deploy in the US, then you're going to access that. Oh, that's not good, guys, because when your microservices is currently deployed in the US region, so you will notice that you will experience the high latency. High latency, that means you will trying to access the microservice in the US using high consumption, and then you will experience a high cost. If you're going to deploy microservices in Singapore, which is the nearest to the country, our country, Philippines, you will never experience the high cost or latency. Even though 2 centavos difference between US and Singapore, that's okay. They're saying that US is much cheaper than Singapore. No, I don't think. Yeah, that's correct. In terms of the pricing information, when you try to use that actual microservices, when you try to monitor, you will experience high latency. Because of high latency, you will get high cost compared to Singapore. The Singapore, which is the nearest place to your region or our country. Okay, that's what we are talking about, high availability. If your client is in the US, just to make sure that you have microservice deployed in the US. But it's not necessary for you to deploy microservices in every country. That's not necessary. So what you can do is deploy microservice every region, or only we have 5 regions or 3 regions or 2 regions. It's up to you. If you're targeting the client in the Philippines, why I should deploy the microservice in the US? It doesn't make sense for me. Because of that, you're targeting the clients in the Philippines, then your microservice is deployed in the US because it's much cheaper. I understand that, but in the reality, you will get high cost. Okay? Oh, that's good questions, Benson. Yes, it can be solved by using seeding and edge server. So, seeding edge server, there's the caching, the request and response. to your microservice. For example, instead of calling the microservice in the US, the sitting edge server will automatically launch your microservice into the nearest region to your country. That's fine. That's fine. If you're going to use the sitting edge server, that will optimize the cost. But for me, I rather choose the nearest region. At the same time, I'm going to use the sitting edge server for the request, for managing the requests, handling the requests. That is much cheaper than when you deploy microservice in the US region. And just try to compare that later. Later, when you try to deploy microservice in the US, when you try to at the same time you try to deploy the US, and then you can use sitting edge server for the two. Then you can compare between two. The next one's high scalability, guys. Vertical scaling versus horizontal scaling. Usually, our microservices, we're not going to use the vertical scaling. When talking about vertical scaling, it is related to the virtual machine. When you experience the load test, the load performance issue, you can use the virtual machine, and you can increase the number of instances for the virtual machines. So vertical scaling is much expensive. It's much more expensive than horizontal scaling. When you're talking about horizontal scaling, you're going to increase the number of application, or reduce the number of application instances. Once you reach below than 80%, it's up to you about the CPU load or threshold that you can set. But I would recommend you to set that 80% or 75% in the CPU load or threshold for the horizontal scaling. So when you use a microservice containing platform, I'd rather choose the horizontal scaling in terms of application, but in terms of increasing the cluster, the number of cluster, then I can use the vertical scaling. Okay. It depends. If your client is in the Philippines, and the depositor, they are also from in the Philippines, so I would prioritize horizontal scaling for over vertical scaling. Okay. The third one is self-healing, meaning when you encounter some errors inside the old container because of your Spring Boot application, that will be replaced with the new container. So it will automatically restart. Okay, guys, when you deploy the new container containing microservices, the new microservices, so you will not experience downtime. Also, your old microservice will be replaced with the new microservice. Once the new microservice is successfully up, then your old container or microservices will be shutting down slowly. Okay? So, when you talk about high availability, that means no experience downtime, which is you will not experience high latency. When you're talking about high scalability, you will not be able to experience the load performance issues. That's high scalability. And self-healing, you will never experience downtime when you try to change the configurations or deploy another microservice, a modified microservice. You will never experience downtime. That is not self-healing. So when you're talking about self-healing, that's the time you encounter some errors in the previous container or container. So the platform itself, the container platform itself will be the one to heal your your containers and replace with the new ones. Actually, you're not doing the setting up the self healing. It's already part of the features in OpenShift and Kubernetes. But for high scalability, you're going to set that in YAML file. From the YAML file, we have different there, like deployment config YAML file and deployment YAML file. Okay? For the strong security, of course, what I have previous mentioned earlier about the strong security, you notice that there is a microgateway. The microgateway is the bridge that will protect access to your internal microservices on the private network. And then also we have JWT authorization, so not everyone can get access on the API, because JWT is based on the browser username and then also IP address. The public IP address JWT inside the JWT header containing that the different the values such as browser, which browser that you are using, which location right now, where are you right now, and then also a username. And so it's impossible for other developers to use your JWT, but the developers is another network, is another different browser, so they cannot access that. Yes, Irel, thanks for the question. Is it possible to access different version of API in microservice? Yes. How? Yes, we have different versions of API inside the microservice. So you can define the context path. For example, domain slash v1 slash service name. Then the API version, we have domain slash v2 slash service name. So you have, for example, you have a cache deposit API. Then the previous version 1 that you have deployed into the current microservice. So the business user decided to use the newer version, which is version 2 for the API. Then you're going to implement the version 2 in the deposit microservice. So now we have two versions of APIs such as v1 and v2 in the context path without affecting the API. Here, that's really good question. That's a very important, guys. You don't have to modify, guys, the existing API every time the client has requested you to change the requirement to update something, and they have another new requirement. You don't have to remove or modify something, because in case they have changed anything their mind, you cannot revert it back to the version 1. Then you are going to look for GitLab repository or GitHub repository. You're going to search the whole repository. So it's hassle for us to do that, guys. So instead of removing or modifying the existing version 1 of the API, you have to create another API path inside the deposit microservice.
Okay, let's go back to the strong security, guys. End-to-end security, meaning um, during the API transmission or data transmission, when you call the API um, which, from the third party, just to make sure the data should be encrypted during transmission, and from the third party, and they want to get your data, and they should call our microservice a cipher microservice to decrypt the API data. So if they are using the JWT, for example, when you post the API request and then including the JWT header, but it's not necessary to put the JWT inside the body request. That is the browser. So we're going to submit the JWT to the API provided from the third party. Actually, they will be able to access your JWT so that they will be able to execute the decryption, this cipher API, so that they can get the data, something like that. So yes, we're going to use that into insecurity in terms of banking and financial security concerns, guys. So from the client side to the service side, before you submitting requests to the service side, your requests should be encrypted in the client side. Once you encrypted the request, then you can send it to the server side. From the server side, they are going to decrypt the request. From the server side, they will not use the JWT for authorizing the decryption API, because they have already decryption logic, and then also they already identify the client. They already identify the request which is coming from the client. So I don't think that the service side we're going to use. In case it don't identify the request which is coming from the client, the server side will ask you to provide the JWT. Literally, it doesn't mean you're going to provide the JWT. The client itself, when you submit the request to the server side, then the server side will find out about your JWT in your header from the client. So they will be able to execute the decryption. Okay? That's end-to-end the security. So the last one, the benefit of microservice container platform about resiliency. So that's very important, guys. Without self-healing, you cannot proceed with this resiliency. When you're talking about resiliency, health is about microservices reporting scoring state to take action. For example, your microservices is getting slow, it's not available. So what will you do? You're going to launch another the same microservice that will be able to execute. So you have another microservices that will be able to replace with the current microservice. So what if their two microservices are not running and there's no other requests? So we have fault tolerant approach, and we have the circuit breaker, meaning is not related to the same microservice. It is another request API that will provide specific information. Let us just say the currently our microservices is still processing. They're going to Okay, I'm going to repeat. Currently, our microservices is currently processing. So, in the meantime, please wait for a while, something like that. So you will not experience the server error or internal server error, because the self-healing will take time to heal your microservice. So after that, it will be replaced with a new container, and then your front-end API will not be displaying something like the internal server error, and they will be able to proceed with the same process and same microservice. Okay, that's one of the another feature in our microservice container platform. Okay, so the current, when you talk about current state is not available to take that action. So how can we use that? We're going to use the circuit breaker of fault tolerance. So while self is healing is ongoing for your microservice. You don't have any questions, guys? I noticed some of your messages are retracted, so I don't know. So let me try that. Let me see. So I cannot read all your messages, guys. Okay, let's give a break for 15 minutes. If you don't want to, have a break, just let me know, and then I can proceed with the next slide. Guys, are you willing to proceed with the next slide? I think our next slide is dev setup. Are you ready? Oh, if you want to use the bathroom, let's just let me know. So I'm going to call the one of the subscribes members. Hello, Aaron. How are you?
Yes, sir. Morning, morning. I'm good, I'm good. Bro, I think just a comment para mo interacting at mas narinig ka ng mga tao. I think it's better to have a OBS Ninja. Kasi gumagamit ng OBS right now, di ba?
Yes, yes.
So, yun. Kung do you know OBS? Hey bro, do you still hear me?
Okay, we can proceed. Alright. Alright. Alright guys, we have the microservices then begins here. So we have the test setup. You have to download the STS Adapt Open JDK 14 or 16. But the Eclipse itself, you will notice that they have only until 15. But you can change it to connect to 16. but the level is still the same, but your Java is still 16. That is fine. And then also you're going to download Docker Desktop. After that, downloading the Docker Desktop, installing, I'm going to enable the Kubernetes on Docker. I'm going to show you how to get started with the STS. I'm going to click on Tools, Spring STS. So there are two types of IDE. You can choose the Spring Tools for Eclipse, and then another one Spring Tools for Visual Studio Code. Some of you front-end developers. Okay, it's okay, guys. Okay, you need a break. Okay, sorry, I misheard about it. Okay, hello guys, welcome back. So I guess I can start now. So our microservices development begins. So what are the step setup tools? The first one, install STS or Eclipse. So STS stands for Spring Tool Tool. Then you can download Adobe OpenJDK 14 or 16 because it is being supported by different companies such as AWS, IBM, Red Hat. So there are a lot of several I think companies to support Adobe OpenJDK because it is stable. So when you compare the version between two, uh, Java 11 is the stable long-term support, and then also Java 14. So when you develop microservices, I don't need the core Java. So I do need Java 11 for the Java core improvement. In terms of long-term support, when it comes to Java 14, it's very fast and there's no issue in terms of performance. So that's why I choose Adopt OpenJDK 14 rather than Java 11, the long-term support. If you are core Java developer, of course you may choose the Java 11. If you are a microservice developer, you can install the latest Java version. But right now for the Java 16 is not available to Eclipse or Spring Source too soon. You will notice that there is still Java 15, but you can change it under the configuration in under the preference. Okay, and then also you can download Docker Desktop. Then you can enable Kubernetes on Docker. So you don't have to install the Kubernetes platform in your Windows or OpenShift, Minishift, just Docker. We can enable Kubernetes. Okay, so I'm going to show you how to navigate STS here. So if you're already familiar with Eclipse, go to Spring Tools 4, and then otherwise you can choose Visual Studio Code. So especially for the front-end developers are already familiar with this rather than this one, then you can select here. So for me, I'm fine either way. I'm fine with that. Okay. So when choose the 64 bit, so after you download, and then double click on the file. So it's still downloading. Then let's say yes, of course. You can use the IntelliJ IDE, and then also you can Spring Initializer. That is fine. So if you wanted to generate a Spring Boot microservice and Spring Cloud, that will provide you the zip file containing the Java sources. So we have maybe project in Java, we have different languages, then I choose the 2.52 version. So if you choose the snapshot, that means it's not stable because you will encounter some issue with other plugins not supported. Okay, so you may choose between 2.5.2 to 4.8. Okay, so ID, IntelliJ ID, that's fine. Any IDE you can choose as long as you have the Spring Tools plugin installed inside the Eclipse or IDE. Okay, so again, once downloaded, when you click on the jar file, it will automatically extract the jar file into one folder. And then after that, copy the folder, then paste it to drive C or drive D. Okay? Don't put the different folders. Yes. What dependencies we choose? For example, for the standard groups, guys, here you can click the chooser Spring Cloud. So we have a Eureka Discovery client. If you have existing the if you have the existing legacy application using Eureka, you can use this one. And then you can also use one for Spring Cloud config for the browser. And there are a lot of dependencies here, but some dependencies are missing here. So sometimes you cannot find that there when you try to navigate. For example, I try to navigate Spring Cloud Kubernetes. It's not available here in the browser. Then you can go to here, Spring Cloud Kubernetes that is compatible with OpenShift as well as Docker and Kubernetes, Docker Swarm. So search, uh, you can access them. So by default, Spring Cloud Kubernetes will enable the Kubernetes profile when it detects it is running inside Kubernetes cluster. Even though you do not deploy the microservices inside the Kubernetes, it still works with the Docker. Yeah, it's still working. And then download the Maven, for example, and click on this one. I'm going to show you this. Yeah. So here, when you access the Spring IO to docs, we have a different cloud platforms here, or cloud plugin, sorry. We have Azure, Alibaba, AWS. So if you are going to use the container, I will recommend you to use this one. If you have existing legacy application for the Netflix, you can use this one. Spring Cloud Netflix, meaning you are using the Spring Boot integrated with the Spring Cloud Netflix. Then also we have Open Service Broker, and then also Spring Cloud Console. You can use this one for the console the platform. That you're going to purchase that console the platform, even though it is free. It is free for development, but it's not free for production. Okay, that's the problem. So when you use the Kubernetes, you can set up the Kubernetes platform from scratch in a virtual machine, or you can use the Kubernetes managed service provided from AWS, Google Cloud, and Azure. You can use that, but both are the same cost. It's not. It depends how you use. It's how you deploy. It's how you use the application. How you deploy, and it depends the cost. So Spring Cloud Kubernetes, there's no cost for you running the application, even though that Kubernetes platform is free. It is ready for production use. But I will suggest you to get the certified first in terms of Kubernetes application development and administration. If if you want to use Cloud Farm 3, I guess that is very cheaper. It's not cheaper than the Kubernetes platform. So Cloud Foundry platform is also one of the container like Kubernetes, but you cannot install the Cloud Foundry from scratch in your virtual machine. You can utilize the IBM Cloud or Cloud Foundry like VMware. You can visit website the VMware. They can also provide the Cloud Foundry. So it will charge you less cheaper. I don't think it's very expensive. I tried to deploy the enterprise microservices. There there are limited the plugins or dependencies that you are looking for. For example, there are other the plugins that not exist in the Cloud Foundry that you have dependencies there in your Spring Boot useless. You cannot even deploy your microservices to Cloud Foundry. There are limited dependencies. But the enterprise production, There's no problem with that. There's no problem. If you want to use to a lot of dependencies that support it, if you want to make sure that you're not going to go back, then I would rather choose the Kubernetes than Cloud Foundry. In terms of future requirements, guys, for example, there are clients looking for specific requirements like you're going to connect with a different third-party application like mainframe, banking, something like that. They have a lot of requirements. So future requirements. So I would rather recommend you to use the OpenShift and Kubernetes. For the Cloud Foundry, for the from small to medium business, you can deploy. For example, if you wanted to deploy your website, yeah, this is much cheaper than the hosting provider, guys, than the cloud actually. So it's cost actually it cost will cost only me for me 200 pesos per month. Okay, the Cloud Foundry is amazing. It's amazing platform for small to medium businesses. So then, guys, it's Spring Cloud Community is all. The easy ways you can put here into Maven, and it means all, including service discovery and client to config map. Yes, discovery part. So again, after you download it, once you extracted the folder, I'm going to show you here. Let me get um, yes. So Master and Microservices, they are going to launch here. Look at that, the target drive C folder. I don't have an extra folder. If you have long folder names, it will not work. You will encounter some issues running in the local machine. This one. So I'm going to open it. Yes, cost. It will cost me 200 pesos a month from the Cloud Foundry service. So when you deploy the microservice or website, it will cost only to you 200 pesos a month. Sorry. Thanks for the question, Benson. So I have to complete here. So the next session, I will show you the demo in terms of the complete platform, complete development, including Swagger, including API, specifications, and then manual guide. For the initial here, you need to finish the remaining session. So then, I'm going to show you to create a new Spring Starter project. Uh, either was to the group it should be XYZ is your company, and just to make sure put the microservice because I have a putting standard and design standard in terms of lagging EOP. It will find and replicate this group instead of doing finding the service exact the service name. So deposit, Maven, jar, Java. We have only 16.11.8, but that is fine. Even you have a Java 14, you can configure it. You can still configure with that under the preference. So then deposit microservice. Now, so our latest framework is Spring Boot 2.52. We have a lot of developer tools. Uh, I noticed a lot of developers still using Spring Boot Dev tools, guys. I encountered this before when you deploy when you deploy the microservice into the container. So I noticed it always will start. So I did not restart the microservice because of this one, Spring Boot Dev Tools. You can use the Spring Dev Tools. You can change the scope for the dev environment so that it will not include in the container. So you can, the purpose of using the Spring Boot Dev Tools, every time you make the change, it will automatically restart your server. Okay? And then also we have a lot here, Spring Cloud, Cloud Bootstrap, Function, Task. There are a lot I don't need to use. But for the Spring Cloud Circuit Breaker, we have Resiliency, and we have Spring Cloud Config Client, Config Server. It's more on the configuration. When you use the Kubernetes, I don't need this one. This one, as well as this one, I don't need. But if you are using Cloud Foundry, you can use this one, Cloud Foundry, this Kevin. Okay? Yes? So guys, when you develop the microservice, you have to develop the separate microservice between gateway and then also another microservice. For example, you have deposit microservice. You should not include the gateway, okay? Because that's for business requirements. Sometimes you need to access the skill statements or database, something like that, or you need to execute the third-party APIs. We should not be exposed outside the network. So you have to create another microservice called gateway. So another project, okay? It's kind of fine. I'm going to add this. I'm going to develop the REST API. Then imagine that we don't have the Kubernetes here, but don't worry, we can add that later. So we have the different structure here, deposit. If you're going to develop the API, so the correct structure folder is actually it's up to you how you design the structure folder. So if I'm going to add the package, API, something like that. So if you are going to deposit API, instead of you're doing the deposit the controller, every business doesn't, every business user doesn't understand what do you mean the deposit controller. You're not familiar with that. If you put that the deposit API, the exact name, the deposit API will be exposed on the Swagger. Okay, okay, that's the source. Now we have resources here. This is the internal configuration management. I'm going to application, select that, okay, process, microservice. Then we have the unit test. The click form. This is our dependency, Maven form XML. So we have Spring Boot started 12. We have the task. We have the Maven the plugin. Then I'm going to ask for the Spring Cloud Kubernetes. Um, so in case you don't remember the exact Maven plugin, so you can search here. Uh, Sometimes we use this one, sometimes it's not available anymore. The Maven, let's say Spring Cloud. So just try to navigate here. Here, we have a lot Spring Cloud, Starter Kubernetes decline all. So that is the old version, I guess. Now we can choose this one, not Spring Milestone. So we can choose the directly plugin. Yeah. See. So guys, don't put the exact version. So if you put the exact version, sometimes the exact put version is not compatible with the pairing the Spring Boot version 2.5.2. So you notice that there is an error here. Cannot find because of the group ID. So when you check that cloud, there is the cloud. So request, right click, Maven update project, first update release. Okay guys, sorry. Um, Now it's better. Again guys, don't put the exact version here in the plugin when it comes to Spring Cloud Kubernetes in relation to the Spring Boot. Sometimes when you put the version, it's not compatible with the Spring Boot 2.52. So I'm saying when you put that 2.52, it will give you the exact version in relation to Spring Cloud to Kubernetes. Right? Now, you notice that we have the Java 16 version here, and then you go, but you're still using Java 15, you're getting errors. You're going to change the preference here. You notice there's still 15, there's no 16. So you can still change your 16. Fine, close. Just double check inside the bell. Fine. Then check the Java version. Okay, Java on the OpenJDK 16, you have to navigate to the Open Java series system. Yeah. And here, you have the Adobe OpenJDK 16. And then also, if you're looking for other versions, Java 14 or 15, you can click on this one. And then also, either way, you can choose this app spot or OpenJ9. So OpenJ9 is for Linux operating system. So when you launch the microservice running locally in the container, even though it is Windows, there it still works because our container is running as Linux in Docker. So that is fine. In terms of performance, I rather choose the OpenJ9 than AppSpot. In AppSpot, it is related to Windows. So it is still working. This is still working with Linux operating system in the container. That is fine. So the minimal is Linux is Alpine. Yeah, we have 13 and 16. If there's something wrong with guys, uh, I'm trying to delete the previous one because I've already there delete contents because the same names deposit. So try to create again. Same Spring Web. Stop the stop. Now we have the Spring Boot Cloud Starter. I'm going to add another the communities. So now there's no more error. Yeah, to package API. Choose the REST controller. Produces, guys. Some if you did not specify the produces response format, so the default is plain text. If you are planning to use the JSON, um, you can set that, or you can use boot. For example, here, For now, there's no specific business requirements here. I'm just trying to develop the basic API so that you will be able to understand. So there are a lot of here joiner members are not familiar with the API, so I understand that. Then you have to enable discovery client. Yes. So once you have the enabled the discovery client, the Kubernetes service discovery platform will be able to find you. Then will allow you to communicate with other microservices through the service discovery. Okay? And then also I don't have yet containers, so I'm going to show you if I can launch this deposit microservices in the local machine without Docker. So we need to put the name spring application dot name deposit microservice. Is it work? Is it working? So I don't think so. Like this. See? It's not working there. But it's still running. You can navigate, but you cannot access the config now from Kubernetes. Cache, remember, this is the cache path, the context path. Yes, we have hello world. So according to the requirements in Herald, questions about if you're going to add the version like this, for example, um, was mapping V1. Okay, then start. So it's nothing anymore. It doesn't work anymore. Then if you put the version one, something like this. There, hello one. Okay. Now I'm going to launch the Docker communities. So how can I download? Just to visit website, let's say download Docker desktop. Click on this one. They click on download for Windows. I don't think there's a charge for you. It is free. So once Docker is up, okay. So you will notice that we have the Kubernetes running and also Docker container. So we have images here, something like this. Then volumes, dev environment. So I don't need to use one for dev environment because I'm running locally in the laptop. Okay. So how can we enable Kubernetes on the Docker desktop? So for example, navigate to settings, Kubernetes. enable. So your Kubernetes version is 1.21.1. So I don't need to deploy my microservices and test it in the cloud with in the cloud because I have the Kubernetes container. I can even test it locally before deploy it to cloud. If you have the existing the Kubernetes platform in the cloud, you can even connect to the the, the containerized database or containerized config map in the Kubernetes platform. You can connect to the Kubernetes cloud via Docker. For example, I'm going to show you that here. As you can see, we have a different context path here. So these are the cloud. This is the local desktop, and the context path are the cloud. You can even connect to different the cloud, and then while your microservice is running locally, then you can even debug here. For example, you can even try to enable here debug something like this if you have database, if you have the config map. Okay, so enable, apply, restart the Kubernetes, and then you have to register and sign up with the Docker community so that you'll be able to yeah, download images from Docker. Okay, it's just a free plan, right? Now, guys, imagine that this is a internal configuration properties. That is fine if you want to define the properties here. If you wanted that application properties will be overridden by the Kubernetes config map. Yes, that's possible. So I'm going to show you here. Let's just say here, uh, I'm going to click on this. So we need to check first with the current namespace. If CTL get an S, if you have their default namespace. So if CTL get config map and default, so you don't have a config map, I'm going to create a config map for you. Okay? So for example, I have the complete here. Micrometer, config map, that. This is an example here. We have config map and application properties. Something like this. So micro deposit, then containerized deposit microservice. So application properties file that we are using are similar to the application properties here. So when you launch NetAce, it will be automatically overridden by Kubernetes. For example, I'm going to add the Spring Cloud, Discovery, and that namespace. And okay, default, Spring Cloud, Kubernetes, config map. Uh, so your name, config map, deposit, and now namespace default, default, config name, that is deposit. Uh, that's it. See, it's not yet registered. So I'm going to apply here, for example, xctl apply config map and oh, so you encountered the version is not set. Alright, here, version, time map. Guys, don't think that that is related to our microservice if you wanted to change that version. No. That is the API version for the Kubernetes platform. For example, the config map, what kind of version what's the version we are going to use for the config map? It's version 1. Version 1 based on the code here is not our microservices. It's different to other deposit API here. Okay, so going to check this qtl depth cm or config map info. There's deposit. I'm going to read. Yeah, so we have here containerized deposit microservice. But but it's not correct exactly. That it's just an input app name, guys, but not the. So in terms of Spring application, for example, here I'm going to copy here. Spring application name should be the same with the project workspace name because when you try to access, you do not need to include the namespace there. It will not work on the discovery client. I'm going to create the configuration to be able to get the info at that name. In case if you don't remember, you can click on the value inside. Example here, string value, like value. Inside, something like this, guys. So something like this, you'll be able to get the exact value from the properties here. Okay. Example, yes. So how we do import automatically here? Just press Control plus Shift plus O. Well, automatically import this line. Okay. Now I'm going to get this. I config get name. So magic clean is built automatically, guys. This is the basic. You're going to need to understand how can we connect to the Kubernetes config map, guys. If it's not working, let's find out how can we resolve the issues. Yes, deposit microservice, meaning you're not able yet to get the containerized deposit microservice, and this one you're getting the input of name deposit microservice. So let's just double check why I cannot connect to. Yes, unable to get the config map deposit in namespace now. Even though I already declare the Spring Cloud to Kubernetes decline namespace, maybe I'm going to show the complete source code here. Example, resources, main, sources. So we have different here. This is default properties, and this the prot seed UAT bootstrap properties, meaning the difference between bootstrap and application. These properties will be updated before the Spring Boot launch. Then once it is launched, then the next application property will be able to read inside bootstrap the properties. So, this is an example here. So you can even change the port legacy. So I have here decline in space. So we're going to add first bootstrap. I'm going to change the server port if you want. Oh, what's happening here? So from here to start, this is the previews. It says here trying to standard configuration to create the Kubernetes API client because you're not running inside the Kubernetes. You are running in the local machine and you're trying to connect to Kubernetes. But it's still working because they will create automatically standard API client. Once you have the created standard API client from the Kubernetes, you will be able to access the config map. As you can see here, we have located property source here. Bootstrap properties to config map deposit default. Imagine that you are accessing the default namespace and then config map deposit. So your profile activation skipping. So we don't have here. Now I'm going to check what will be input admin. Nice. Let's say okay, it should be here. So I'm expecting that output will be like this. So because I changed the port, remember that guys? Okay. So what will be port? Oh, still the same. So let me check. Why is it that? So I have to enable first the client config map here. Config map here. I don't need the secrets. So meaning reload enable truth is falling every minute or every second. I think every 15 seconds. It always checks on the configuration changes. If you have a changes in the config map, your Spring Boot will automatically reload. It doesn't mean it needs to be shut down. Okay? It doesn't mean. I think that's fine because we don't have a cluster environment here because you are running the deposit microservice locally, but you're trying to connect to the Kubernetes platform via Docker. So hopefully we can get the Kubernetes config map that it should work. So let me just check the all discovery clients now available. Okay, stay the same. So I notice what happened to here. It's loaded the config map. Okay, let me try to update, guys. If automatically restart, it is working. Okay, so again, then you're going to apply the changes to config map. Oh, I see. So it's not really there. So I found the exact issue here. We need to add this one, legacy. I'm going to transfer. It doesn't react to this one. We try reload again, maybe. Let me figure out this a while. Need to fix that. So the is why does it work? I try two other options. Is config man focus. Config map. So if you instead all, I'm going to try to use the direct config map. Mm. This is correct. And the falling back to default properties default. In my perception. Fine. Fine. Yes. See, guys, it's finally working. Sorry. But the complete source template is totally working, totally completely working when I provide the template. But there's a 1 year warranty, guys. We can update, we can test it. I'm going to show you how to test the microservice. As you can see, guys, externalized configuration. So I noticed that there's no React on the server side because it is running locally. When you running the microservices inside the communities, there's reloading the server. It doesn't mean we start. It doesn't mean need it to be shut down first and then start. No, that's not like that. So when you have the microservice running in the local machine, and then you're trying to connect to the config map, externalize the configuration in the Kubernetes platform, then you'll be able to see the updated changes, the Kubernetes. So imagine that if you have the cloud, guys, if you have the externalized the configuration in the cloud, when you are using Kubernetes, then you try to connect them via Docker. It's possible for you to access that. Even though that we're going to connect the containerized database, configuration, service discovery. So the difference between all and config, guys, here, when you say config, only the config map feature you're going to read. When you say all, you're going to read the service discovery available in the Kubernetes platform and implementation. And then also you are trying to explore more about the features uh, service discovery, then deployment, something like that. But in config, it's only for config map and secret. When you have the sensitive data, guys, and try to put their encrypted value. Okay. For example, I have another example here. The secret. For example, here I have a secret here. Spring mail using password, using password. Something like this secret. Okay. Nobody read your password. When you access the competitive platform and then you are the admin, you'll be able to view. But the application itself, like microservice, cannot read that, cannot view undecrypted value. Ano? But the application will be able to get the Spring mail username. Even, even if it's already encrypted, it's still working. Okay? So what is the next then? So I'm going to create the model, guys. Another thing, example, another structure model. This is about the domain model. For example, uh, cache request and cache response, something like that. And then also we have another package that component. The component contains the different Spring Boot security features. For example, you're going to update the JWT configuration, JWT authorization, JWT authentication, and then also other the features. For example, going to show here micro features, monitor source, main, Java. Oh, okay, I'm missing there. Okay, the other examples we have the complete here. Yes, for example, we have a token provider, we have a JWT authorization filter, authentication entry point, buffering clients, TTP response proper messages. So messages is terms of internalization. For example, you're going to respond the exact in this conversation, but you can switch to, it depends on the browser that you are using. For example, Chinese, and they are trying to access your application. It, your English conversation will automatically be translated. Your English content as well. Okay? So, there's no hard coded in Java, guys. Uh, we can use the properties file, and then also we can use config map as well. Okay? So I guess for now that's it for the basic, guys. So do you have any question for this? For the next meeting, I don't think that we have another concept for the presentation, guys. So it's most likely it's more on the development setup. It's more on. I guess we are done with the development setup. The next is we're going to create the API as well as Spring Cloud, Spring Cloud Gateway, also Spring Cloud Circuit Breaker. But I don't think I don't think this is complex because unlike here the deposit microservice, you need to put the business requirements there. So it will work needed here. For example, okay, this is the last one, guys. So I'm going to create cache request, private string, account number, something like that. Private string, account, amount. So destination.
Guys, for those who are not familiar with Java, so I would recommend you to explore the Java basics with HackerRun. For example, I'm going to show you how to navigate here, HackerRun. So we have actually this is for free. You don't get any charge. Then you can get certification here for Angular and then also Java. For example, click on the Java. If you're the first time, so you can solve the challenge here until advanced. So we have medium, easy. I already registered here just last month, so I already finished here. So you can meet also with other developers, but it doesn't impact you. It doesn't impact your performance here in Java. When you get high score, uh, other several other several IT companies will be able to impress your profile. Okay, when you get high scores in the hackathon. If you don't want to show your score, that is fine. Then set the you can set your profile to private. Okay, and then also you can join also compete jobs, leaderboard. For example, once you join the contest, your name will be listed here. Okay, for example, that's something like Java, 93 score. Okay, okay, this is the last one. Yeah, I'm going to finish because it's all. Sorry guys, it's almost 12, so I need to finish this one. The last one, one more. If you have more questions, guys, you can post your comments or chat box. So that is fine. It's still working with the application JSON value. So our application input at lane, that's deposit microservice. see. So it's account number, but we don't have I I noticed there's no info at name because I did not define the getter and setter properties here. So you need to use the getter set getter class as input at name. And you wonder that guys that you're going to use the project Lombok to eliminate the setters and getters, guys. It is working for the microservice. The thing is, it it doesn't work with the Swagger UI. So I tried that before, it doesn't work. So it is working for the APIs, but that is not working for the Swagger UI. A Swagger UI, that means API documentation you'll be able to see. Okay? For example, okay, let me just finish here. Getter, create a start. Okay, you see, part 4. And then, for example, open API Swagger UI, something like this. So, yes, something like this, guys. This is the Swagger UI, API documentation. Instead of putting the Swagger individually in each microservice, we have microgateway. We can put there in a microgateway. So while you develop the local microservice, not for the microgateway, you can still use the Swagger. So again, it is not uh, when you are using the Lombok, it is not working for the Swagger UI. For example, here it is working for the API, but you don't see the parameters here because there are no getters and setters that you define. Okay. So any more questions? Guys, again, we have another session too for the next week, and then we will not discuss about the concept. I guess I guess you already understood the requirements of microservices and design pattern. Then I just want to make sure that you apply the best practices, and then you apply the pattern. How we migrating from monolith to microservice, and you need to be aware of which microservices patterns that you're going to use for Microsoft. For example, the existing microservices that you have already API gateway, so we should not include the API gateway pattern because it's already there. So like AWS, Azure, GCP, something like that. Okay. Um, it's more on challenging for the next week, guys, Saturday. Uh, so are you comfortable with the time from 8 a.m. to 12 p.m., guys? It's still because we need to finish the whole session um, regarding the cloud, Spring Cloud, Spring Cloud Circuit Breaker, fault tolerance. So I'm going to show you some the requirements here, like Spring Boot, microservices. So for the next week, here I'm, I'm going to implement here Spring Gateway. Then I'm going to change this with deposit microservice with global microservice. There are two, and then also we have the config server. So for the config server, it's applicable for the global configurations. Even though that you have a container, then you can still use that. You can apply the config map. Remember? So imagine that For example, this is a microservice. Let's try to imagine that we're going to switch to config server here. And then we have the config map here outside the project, right? Outside the Java. So you can still use that in the config server. One, but the problem is application.properties is for whenever you make the change, the config server needs to be restarted. Unlike the config map, without the config server, it is still working. Okay? So, any more questions, guys? So next time, it's more on laboratory. So the previous is the session 2, July 17th. Have a nice day. Thank you, guys. So, thank you for the question, Charles. Yeah, for the reminding that I should be closer to my mic. Have a nice day. Thank you. Thank you for joining.